Okay, in this video we're going to review a unit of concentration called molarity. Molarity is equal to the moles of solute divided by your liters of solution. So let's look at what those words mean, solute and solution. And we're going to also bring in another word, solvent. If you have a mixture, the component of that mixture that's in lesser quantity is called the solute. The component that's in greater quantity that you're dissolving that solute into is called the solvent. And then the mixture itself, the solute with the solvent, is called the solution. So if you have a solution of sodium chloride that you've mixed into water, the solute is going to be your sodium chloride, the solvent will be the water, and then the solution is going to be that mixture itself, the sodium chloride that is dissolved into the water. So how do you calculate molarity? The easiest molarity problems give you units of moles, give you units of liters, and then all you have to do is divide. So say you had 0.52 moles of sodium chloride, and it was in a total volume of 1.6 liters. They gave you moles, they gave you liters. It's simply a plug and chug, moles divided by liters. It's just going to be 0.52 moles divided by 1.6 liters. And that sodium chloride solution is going to be 0.52 divided by 1.6, 0.325. So we'll go ahead and call it 0.33 molar since we're using two significant figures. Then molarity, you can write moles divided by liters. It can look like this. But more commonly we see this abbreviation, the capital M, stands for molarity. This means moles divided by liters. So does it get trickier than this? Well, of course it does. You could be given a mass in grams of your solute. So what if you said that you are making a solution, we'll just stick with sodium chloride. Say you had 10 grams of sodium chloride, and we'll give you those liters again, 1.6 liters. Right? Molarity is moles of solute, right? So what do we have to do to these grams of our solute? Have to convert them to moles. We say X moles of sodium chloride equal our given information, 10 grams of sodium chloride. Put that over 1, and then we have grams of sodium chloride that become our denominator to cancel out. We're looking for moles of sodium chloride. Whenever you're doing molar mass, the number that you want to associate with moles is 1, because molar mass is the mass in grams of your substance in 1 mole. Okay? Sodium chloride, it's about 23 grams per mole for sodium, about 35.5 grams per mole for chlorine. Going to add those up. Our molar mass is about 58.5 grams per mole. You got these numbers from the periodic table. Remember, you find the masses at the bottom of the element symbol on the periodic table. So we have 10 times 1 divided by 58.5. I'm not going to enter times 1 in my calculator because that's not going to change my number 10 at all. So 10 divided by 58.5. I get 0.1709, so I'm going to call that 0.17. Okay. So molarity is moles of solute divided by liters of solution. I now have moles of my solute. I was given liters of solution. 0.17 divide by 1.6 gives me a concentration of 0.106 molar. And we'll go ahead and call that 0.11 molar. Okay. So there's only one more thing that could make it more difficult for you. If you're given a mass in grams, you have to convert it to moles. Sometimes you're given a volume in milliliters, and you have to make that conversion to liters. So let's see what that would look like. What if instead of 1.6 liters, we said that this was in 420 milliliters? Well, we would have to convert those 420 milliliters to liters in order to calculate our molarity. Right? So we want to know how many liters are in 420 milliliters. Given information over 1, the unit that we don't need anymore in the denominator, what we're looking for in the numerator. The bigger of the two units is going to get the 1, and the conversion from milliliters to liters is going to be 1,000 milliliters, or a liter. Right? So essentially, what we're doing is dividing our milliliters by 1,000. That's going to give us 0.420 liters. I'm using the same value for the moles. I'm going to take my 0.42 liters and divide. So in this solution, I've got 0.17 moles divided by 0.42 liters, and that becomes 0.404, so about 0.40 molar.